Hi, Mark. Hello, everyone. And thank you very much for having us. Just to let you guys know, my name's Luke. I'm the CEO and co-founder of Alora, and this is Rory, the CSO and also co-founder of Alora. Just to give you guys a bit of an idea of actually what Alora is, the best way to describe it is as an ocean agriculture company. And essentially what we mean there is that we grow rice in the oceans. So we found a way to be able to activate dormant salt genes inside basically every crop that we currently use today and actually make those switch on so that they can handle high amounts of salt, whether that's on land or even in the ocean itself.
I'm going to go back just a quick second. You said dormant cell. What was that?
Dormant salt genes. So these genes essentially you can find in nature as well. So mangroves, seagrasses, anything that already exists in the oceans has these genes already switched on, and they work perfectly well. They've been developed by nature themselves. And what we found is that all those are already in the crops we already use.
I just saw a whole thing on mangroves in Baja California 2 nights ago and didn't realize that their ability to sequester carbon is about 10x that of anything else. Have I got my number right there, Rory?
Yeah, you definitely do. They're phenomenal for sequestering carbon, and it's a very important part of that ecosystem. And it's something we try and bring into our design as well with these floating farms. It's all about a new age of agriculture and making sure that it's not just good for the people that need food globally, but good for that ecosystem of the environment.
So I've heard of aquaculture, and I think people have thought about the things we can naturally, that we grow kelp for all the things we grow kelp for. Here in Santa Barbara, we have mussels, a huge mussel farm, which is fantastic for proteins. And we had a talk in 2016 about doing aquaculture and fish farming. But the thing that intrigued me was I didn't think you could grow this type of plant, because I think the video you have or these huge seabeds, just acres of rice growing on the ground.
Yeah, and that's exactly why we kind of started it. You know, in the beginning, we were all crazy. Who would think to be able to take everything that grows in a field and put it in the ocean? But all the nutrients are already there. The whole idea of being able to grow in the oceans is most akin to hydroponics, which we see today, perhaps even in the supermarket already.
Sure.
And all we're doing there is just taking that same concept and providing the salt ability for our plants to survive, and everything else is taken care of by nature. So you get
that's the trick, the salt, right? That's the trick. Because
if you like.
So do we all have this? So what did you call it? A dormant salt gene?
Yeah. So every plant that we've currently studied does have it. It's a pattern of around 8 genes, give or take, depending on how salt tolerant the plant you want to be can be, and it essentially manages salt entering the plant. So if you already have, and this is how people have often thought about like salt tolerance, it's why no one has really cracked it to this day, because we think of the oceans as this very hostile environment.
Right.
You put a plant in, it's probably going to die. But it's not actually hostile. When you look at things like mangroves and seagrasses, they have a completely different system to what we thought was salt tolerance. And it's about managing and adapting that salt to actually benefit the plant. And that's what we do. The whole idea of Alora started out as we're going to solve world hunger. That's our goal. It's a pretty lofty goal.
Set the bar way up there.
Yeah, it was like, if we're going to do this, we might as well go all the way. But it's evolved now into more the whole idea of agriculture and actually adapting to make a sustainable system. So if we're going to do this, we're going to create ocean agriculture in saltwater for the first time, then we need to be able to do it in a sustainable way. And that means ensuring that any impact we're having mimics what's already done in nature, so much so that it can just slot into that ecosystem, nicely done, without having any adverse effects.
Give me an example of an impact, because it seems to me you've kind of mitigated all the ones that come to my mind at first.
Yeah, so when we're talking about environmental impact, it's always about either having a neutral or positive impact there.
Yeah.
And in the way that mangrove forests and seagrass meadows are real cornerstones of that ecosystem. They're huge providers for whether that's fish stocks or other organisms and anything else you can really think of. They're the whole pivot point of that ecosystem. These farms can really act in the same way. They provide shelter for fish stocks. They can they can introduce net productivity into a region, into that new ecosystem. And all of that is done without adding any pesticides or fertilizers into that ocean column. And we're actually taking methane out of the atmosphere, deactivating it, so it no longer has that very potent global warming greenhouse effect, and adding that as fertilizer to the plant.
So, so one question comes to mind is, who actually owns the seafloor?
That's depending on where you're looking. So if you consider any country, it has what's called an EEZ, an exclusive economic zone. It's normally about 200 kilometers from the coastline. Anything that's fallen within that, owned by the government of that local country. Anything outside of that, it's really fair game. It is governed by what's called UN Class, which is like the United Nations law of the open ocean, the ocean sea. And so there is some maritime law there, but it's more of a general convention rather than a strict law. And so we tend to look more towards within the EEZ and working with local companies, local countries, to make sure that we can get it as close to shore as possible, cutting down on that distribution time, but also just it's better understood in that area. It's more nutrients too.
I'm gonna guess that this wants a sandy bottom, and just from the ease of use of doing all the work that needs to be done, you want to have it close. Is the work all done by divers, or do you guys see a world of machines that do this?
Well, at the moment, we're just focusing on the surface of the water. So having these floating ocean farms.
Well, they
on the
float.
surface. Yeah. So if you imagine the top half of the plants themselves, so your leaves, your stems, your grains, all on the above surface. The roots, they're all going into the water and they're soaking up the nutrients from that solution, basically.
Okay, so did I see a video where they were on the ground or they were on the seafloor?
Yeah, so there's actually a really interesting company in Italy, in northern Italy, called Nemo's Garden, and it was one of the early influences for us. And they sink their domes underneath the water and then ring the outside or the inside of the domes with these herbs that use like the evaporation to actually water those plants, which is pretty cool.
So I could see you having these floating gardens. I like that, the visual of that. They could be kind of hundreds of miles long anywhere, but you want to keep them out of sea lanes and all that kind of stuff. Is there a, so we know there isn't an adverse effect. Is there a positive effect of doing this?
Yeah, at the moment, we're starting to see a lot of positive effects. The main ones, if you're comparing it to land agriculture, is that we're not using any fresh water. So fresh water today, I think 70% of it is used for agriculture. Only about 10% is actually used for drinking water. Imagine if that whole 70% is completely negated. When we're moving in an area where more than ever, the rate of global warming, the rate of carbon dioxide increase in the atmosphere is increasing beyond what's ever been seen in history. This is more important than ever to ensure we have a stable source of water. We don't use any fertilizer, no pesticides, no herbicides, we use very minimal land. 2/3 of the world is covered in salt water, so there's no issue there. Yeah, it's a, when you think about it, when you go through the steps, we started to realize that it wasn't just about solving world hunger, and that's why we've moved into this grander scale of how do we establish a foundation for society to be able to grow sustainably and actually integrate into nature at the same time.
One of the things when I hear a story that sounds too good to be true, which is like our hobbits finding a pile of gold only to determine there's a dragon hiding underneath it. What's the dragon in this story?
I guess the dragon is the traditional agriculture in a way. It's
big ag.
Such a crazy idea to do this, that shifting everything into this completely new form of agriculture is a monumental task. And so having opportunity to talk about what we're doing, educating people on exactly how we do it, we try and be as transparent as possible. You know, it's not magic, it's just lots of work to get.
Did you have to do you have to genetically modify the rice to be able to unlock this dormant salt gene?
So that's
How do you
really
do
key.
that?
Yeah. So we don't modify them, but we do engineer them, and there's a very like fine line between the two. So we're not taking anything from like bacteria or other plants. That's all, you know, kept on one side. What we do is we just change how much of a gene is found and where it's found in the plant. So you can think of it like if you're building a table and you already have the table structure, you have the legs in there, you have the top of the table, it's a table, it works. But if you want it to be stronger, you need more legs and so it can support more weight. So all we're doing is just adding more legs in. And all that's already in there. It's just about distributing that weight across a wider area, a wider surface area to make it a bit easier to manage.
Now, you guys, did this research come out of work you were doing in university?
Not exactly.
With the tools that we gained from university definitely helped along this whole journey of being able to, for one, come up with this idea and then create it, make it real. But really, Luke was the one that first had the idea about how you could move agriculture from land into the ocean and unlocking that true salt tolerance. And you did that just by hard work and really diving into what is genetically possible, like what each plant has the capability for and how we can utilize the existing infrastructure within that plant to make it better, to really use what nature has already provided.
Well, knowing that rice is such an important staple, you know, to solving world hunger is a big deal. Are there any other grains? I did a quick little Google search to see salt tolerant, but we're not talking about salt tolerant. We're talking about something completely different. Are there other grains on the roadmap for you guys?
Yeah, there definitely are. So we want to be able to work in every staple and every crop that the world needs. And
really?
Part of that is moving on from rice as soon as possible. So we're going to be working in corn and soybean this year and be able to get that worldwide coverage and be able to feed as many people all over the world.
We want to be able to do small farms with like herbs and leafy greens. We want to do giant farms with grains all over the world wherever we can. Cities, rural areas, doesn't matter. We're not picky.
And a big part of that is using local varieties as well. It's something we've realized with rice agriculture. It's very culturally specific. And we can go to any region and use any local variety that has a specific taste or cooking profile, and we can make that salt tolerant. And in that way, it really means that we can tailor it to any region in the world and any mouth that needs feeding.
How long does it take to take a given, I'm thinking of red Thai rice, for instance, and there's clearly a lot of coastline there in Thailand. And let's say you're going to do that there. How long does it take from the time somebody, probably a government agency, says, okay, let's do this, and they do a trial? How long does it take to start with regular red Thai rice and get to a salt tolerant one?
Yeah, so up until now, it's normally taken about 6 months for us. And we're actually just working on, right at this moment, the newest level of our design. And so right now, the plants we've got can go up to about half the salinity of salt water, or oceanic salt water. It's about 16 grams per liter, which is a world record. It's the most salt tolerant rice plant on the planet, and it's just growing behind us. And we know exactly how to take it from the 16 grams per liter to the 32, that full maximum oceanic salt level tolerance. And so what we're doing right now is saying, okay, once this design's in the process, once it's taken through and being able to understand that impact, what we can do is say 6 months normally for a grain, let's say one growth cycle plus about a month for anything smaller than that. So for lettuce, for example, would take us about 2.5 months. For corn, 6 months.
How many years realistically do you think it's going to take before you're contributing a noticeable amount of tonnage to the world's need for this food?
This year, we're actually about to start planting in Vietnam. So by the end of this year, we expect to be able to have our first field in salt water levels, that irrigated, by salt water, but on land. Everything we're trying to do right now is going more towards our ocean agriculture, which is where we see the company moving, to where we see the future of agriculture moving. And that's going to be headed in a pilot in Singapore between now and the end of 2023. Once that's all wrapped up, I'm going to say by the end of 2024, we'll be commercial with ocean agriculture, and that'll be a significant amount in Singapore, perhaps in a few other countries around Southeast Asia as well. We're also looking at the eastern side of Africa.
You guys, this is so exciting. I'm so glad to have met you and introduce these ideas to our TEDx crowd.
Oh, it's fun, honestly. It's a pretty wild idea, and it's just a lot of fun to be able to share that vision and hopefully inspire someone else to do a similar thing.